Well, hello everybody, and welcome back to another action-packed, exciting episode of Classic Arcade Repairs. This, if you can't tell, is a Tempest board. This is the main board of a Tempest. Now, Tempest consists of this and an auxiliary board. I do have a good auxiliary board somewhere over there that I'm going to pair with this for testing. The reason I got this out to repair is I got my circuit boards that I designed. This is my single ROM PCB that goes right here. So what I want to do is populate this. I'm going to repair this as a regular Tempest with the EEPROMs because I want it to work as it should. And then what I want to do is I want to switch and put this in and make sure it works with my PCB. That's the plan. So first thing I always do with boards like this is check all of the software, make sure that is all good, and then we'll go from there. This Tempest board set, by the way, is one of my friend Todd's. And yeah, since I'm using it for the guinea pig for this, I got to repair it. Todd will have an extra main board, because this is his. So once I'm done with this will go back to him. So yeah, there you go. Let's get to it. Okay, we got the big guns out on it. I dumped all of the EEPROMs. They were all good. So I just, using the fluke here, I went through this whole bank of EEPROMs here, and I'm okay. But I have incorrect access to the vector ROMs, and I have no access to any of the RAM. So we're going to have to figure out, these RAM right here I believe are the CPU's work RAM. These four, I forget, I don't remember what the ranges are. I think it's 2000 to 27 FF maybe. I don't remember. And then you have vector RAM right here, which is 8 2114s. Yeah. See, these 8 guys right here are the vector RAM, and then these 4 here are the CPU's work RAM. So I need to get some documentation on what exactly is. I bet you I have it over in my filing cabinet. I'll pull out the Tempest file and see what's going on here. Okay, so what we're seeing is, let me turn this back on. Okay. Oops. Let's do a RAM short 0 to 7 FF and loop it. Okay, that's trying to read from these RAM. And it's telling us that AF are bad. So basically I looked at this and find the RAM side, because I know that the ROM is all good. This ROM anyway, all of the program ROM comes back good, and that comes back on the CPU side of the data bus here. This thing right here, all this 245 does is this one. All this 245 does is this RAM, the working RAM. Okay. Now I can read the ROM good, so that tells me that my path back to the CPU for the ROM obviously is good. This guy is what's in question right here, this 245. Now I jumped a 245 over it and got absolutely no difference. So remember, that doesn't always work. If this thing is just blown out completely, shorted to ground, it'll short your jumped chip out to ground as well. So what I'm doing here is I'm looking at the RAM side and the lowest bits are pins 2, 3, 4, 5, and the upper bits are 6, 7, 8, and 9 on the RAM side of this 245. And it's telling me AF. So that would tell me that the upper bits have 2 good bits, 2 bad bits. So the very most significant bit is good. So this is what I should see. If I start on pin 9 of this, if I start on over here on pin 9 and go down to pin 3, that's going very most to very least significant bit. I should see good, bad, and then all bad. So that's what we'll do. We'll start pin 9, because good, bad is F. And that is not the right chip. This is the right chip. Boy, I can't hardly get to it. There's good. That looks good. Next one is bad. And that don't look bad. I'm on the right chip. Good, bad. Anyway. Yeah, that don't look good right there. That looks good. That don't look good. That don't look good. This one's iffy. That one looks that one looks okay. Possibly. That don't look good. Yeah, and all the control signals look good. So what I want to do is I'm just going to clip this chip right out of here. I'm going to turn the power off, and I'm going to clip this chip out and then look at those pins again and see if they look like they make more sense. So let me do that really quick. I'll be back. Okay, well, I replaced that. I cut that out and replaced it. That was not the problem. It's the exact same issue. I'm looping right now. Same thing. So we either have, the most likely case is decoding, a decoding error. What does it tell me with, I don't, what is this RAM? What is that RAM range? Program ROM. Where's vector RAM? Vector RAM is 2000 to 2 FFF. 2000 to 2 FFF. It tells me AD, and if I loop that, see, gives a little bit of flakiness. I saw it flake. So I might be able to jump some of those. I think I killed this RAM by jumping it backwards. I think I killed it. We either have decoding or we have a bunch of bad RAMs. Just kind of watching the fluke as I do this. Okay. It's making it move. I think I may have killed this. I'm going to go grab a new RAM and try it, because I think I killed that one. Alright, I found something that looks a little strange. This is a 245, and I'm taking it, yeah, that is the RAM buffer. Video RAM buffer. 245. I need to look at the schematic and how is this interfering with this RAM? How this RAM goes back through this. Are these two, are their paths connected? Let me look at that. Okay. It's kind of weird. The high side of this one and the high side of this guy look like they're tied together. But they sure don't act the same. Yeah, I don't know. I don't know what's going on. This is weird. I need to look at this a little bit. Let me look at it one more time. Now, this is the vector section here. You got your vector RAM right here. And those data bits are going through H3 right here. And the high side of H3 is the CPU side. And it's directly a direct connection to the CPU. That's H3. That's this one right here. So that high side is the data bits that are connected directly to our CPU. Now I believe that's the same thing with this guy right here. I think that'll be right here. See these data bits go through this one, which the high side is also directly connected to the CPU data bus. So how come this doesn't look totally the same as that? This doesn't make sense. If these are connected, they should look exactly the same, right? The signals. So if data bit 7, which is pin 11 of this guy, pin 11, this should look exactly the same as data bit 7 of this guy, which is data bit 7 of this guy, which is pin 9. Oh, this is the short, this is different. This is pin 9. Pin 9 of this guy. Yeah, it does look the same. This one's bad. This one is corrupting this one. That I thought it was this one. I believe it's this one that's corrupting everything. So I believe that's what's going on. So I think I want to remove this guy. And this one is hot. And this is the RAM side. This is the side coming out of these RAMs. And it looks fine. And the other side, granted, it's not enabled, so these should all be, this should not be influencing the bus at all. And I tell you what though, this one is also connected. This guy right here, all three of these, this one, and this one, the CPU sides are all connected. So it's one of these, because this one is actually being enabled every now and again, it looked like. Yeah, this one is being enabled once in a while. That's the CPU side. And this is This is the side. This is what this should look like when these are not enabled. Now remember, this one does enable every now and again. This is what these should look like. It's tri-stated. Okay. This is going over to the auxiliary board. This one I would say is good. This one I think is the problem. So I'm going to get this guy out of here. Okay, I replaced that. No change. Same thing. So, okay. These RAM right here go through right here. These 4 RAMs, the CPU's working RAM, they go through this guy. And these are both connected to the data bus on the CPU. This is the vector RAM data, which looks perfect. Looks really good. And then the other side connected to the CPU looks like this. This looks garbage. Okay. Okay, yeah. That's connected to the CPU through. Now this is being activated. I bet. Interesting. I wonder if when I turn the fluke on, this goes high and stays high. I wonder. Because why can I get through to this bank of RAMs fine? This is connected directly to the data of the CPU. That doesn't go through a buffer at all. I don't think, right? Well, it goes, yeah, it does. It goes through E2 244. Okay. So the ROM goes through this. Okay. Okay, so the ROM goes through this. And everything else goes through a 245. I think we just have bad RAM right here that's corrupting everything. Because this is being activated. I think we have RAM over here. I mean, this is where I'm kind of deducing it down to, is these RAM, because this thing is being activated, so the CPU side is being dumped, and it looks like it might be opposite. This might be the inverse of the enable to the 244, so it's doing RAM and then ROM in sync, opposite of each other. Like it's reading a byte or whatever of ROM, and then it's doing whatever it does with the RAM. Yeah, I don't know exactly, but it looks like it's maybe inverse, maybe. I know they're not being activated at the same time. I know that wouldn't work. But ROM works, RAM don't. So I'm beginning to think, and these aren't always active. This is not always active, and neither are any of these. As I was thinking, maybe these are corrupting the, maybe these were corrupting the bus, these input buffers and stuff like that, and drivers. And none of them are active. So, yeah, I think it's coming down to just RAM over here, which is bad. So I think what I'm going to do is I'm going to get my gun out. I'm going to remove these 4 RAMs and I'll test them. And then we'll see. Maybe then I'll put the fluke back on it and see if we can read these. And I think we have RAMs that are just bad and are corrupting the bus. Alright, well, I got to looking at the schematic a little bit and finding out. And basically it came down to getting everything off of the data lines. For the RAM, these ROMs are isolated. The data from the RAMs goes right to this chip. That's it. It doesn't go anywhere else on the board. Data from the RAMs does. It's all the way over here. You know what's funny is it was connected. The CPU side of this is also connected, I think. I would have to use my beeper. But I think that the CPU side of the ROM data is also connected to everything on the board, I think. Anyway, what I did was I cut the 244 drivers, the sample drivers. I cut those off the board and now my RAM works. Yeah. I'm going to have to check. I removed this RAM. This 245. This is the one that talks to this board right here. I removed that. That wasn't it. It's one of these. I cut all three of them off. I was like, I don't really care. I'm just going to replace them all. Yeah. And this is also mirrored at 1000, I believe. 1000 to 17FF. Yeah. And I believe the RAM... No, the RAM is 2000 to 2FFF. Yeah. Yeah. Yep. RAM is 2000 to 2FFF. That's the vector RAM. Might as well test them all the vector RAM. And I'll have to replace a 245, 3 244s. I'll do this tomorrow. And that should, and now my RAMs, these guys should work too. I'll try those out. Make sure that those are good. These were both bad before. Yeah. So looks like all the RAM are good. I did remove these 4 CPU RAMs. I desoldered them and removed them and then socketed them. I tested them. They're all good. Because I was thinking that maybe these were corrupting corrupting the bus or whatever, but it doesn't make sense because these are isolated after the buffer, but they're not isolated to the board. That's what was throwing me. The data bits from these RAM are directly connected to this stuff up here, and it must be directly connected to... I don't think it's directly connected to this stuff. I don't know. I'm a little confused. I'd have to look at it more. All right, let's try this ROM. And this one is supposed to be B0FC. There we go. And the other one. That one is 3 did. 3 did. And there you go. So now all of our Our ROMs are good and our RAMs are good. So we should be good to go once, I mean, barring any vector issues, any logic problems with the vector. So we'll go ahead tomorrow. I'll come out and I'll replace everything that I've got removed. And we'll see where we're at. Okay. So I replaced those parts. And a weird thing was every one of these pots was frozen. It would not turn. If you put a screwdriver to them and tried to turn it, it would just try to twist the whole pot. So I had to use my deoxit. And that stuff, like I say, is the best thing for pots. If you don't have some of that, in the description below is links for all kinds of stuff, and that is one of them. That is the greatest thing for these pots. You just give them a couple of little squirts, let it sit for a second, and then I held the back while I turned them, and they would actually break free. And then I worked them all until they were good. But they were, I've never seen these little pots like this frozen so solid. It was weird. But I got them all done and everything. I got it in test. And test mode comes up nicely. I've adjusted it. Yeah, it looks pretty good. But the minute that I take it out of test, it just does this. So it has no vertical vectorage. So I don't want to leave it like that. So the vertical section, no, that's the horizontal section. The horizontal section is, something's not working right. So I kind of want to just start at the beginning of the vector. And I did test this. This is the state prom. And it is good. But I need to just start probing around in the vector section. And that's what I'm going to do with the little scope. And just start with the state machine and move on to the timer and just kind of poke around and look at signals and see what's happening. And one more thing. This right here is the communication link between the main board and this board. I do want to make sure that the signals with this is a new chip. I know this chip's good. But the signals that are controlling it, I want to make sure that they're looking good. They're present. So I want to make sure that this board can communicate with this board. I know this board is good. So, yeah. All right. I'll be back. Okay, I found something, but I can't duplicate it again. We are doing this with the line, just the vertical line. And I was probing around the very first section here, and I was probing these 670 register files, those guys. And I was looking at the outputs of those. And this middle one had a low all the time output. Now it doesn't. I believe it was pin either 9 or 10 was it was low all the time. Now it's not, which is weird. But what I did when I saw that it was low all the time is I grabbed one and I jumped it over it. And then Tempest showed up. Sort of. Sort of. It doesn't really look like it progresses past this, though. So something is definitely not right here. Yeah, there's something going on here. And I don't know if it's necessarily this chip. I kind of don't think it's this chip. I think just jumping that over that does something to make it do this. It's stuck right here. It does not progress. It doesn't go through the attractor or anything like that. Yeah. So we've definitely got some logic issues. So I'm going to keep poking around, and I just thought that was interesting to show. I don't believe that this is the problem, though. I really don't. I think it's something else. I think this is just exposing a problem, because it won't even progress past this screen. I don't know. I think it's saying press start maybe for is that what it does when you coin it up? I don't know. I don't think so. I don't know. We'll see. Okay, very strange. I just, on a whim, I never liked these chips that I bought. These LS44s were flaky. And I was like, I wonder about these things. And I pulled them out of the sockets that I put them in. And this thing is running now. I mean, it's got issues. But at least it's running. I'm going to put it back on the big monitor and see what it looks like. Alright, now I did put one of my 244s on a little board that I have. I stuck that in this one because this one I believe is for the color RAM. I wanted colors to work. And check this thing out. It works. I was looking around on this thing and I was probing around and I couldn't find anything wrong with it. And just on a hunch, I decided to pull these things out. I'm throwing these out. All of these 244s that I have one more in stock. I'm throwing them all away. I've had multiple issues with these things. Now the problem is I don't have any more. I do have one that I could put right here, but then I don't have one of these. Maybe I'll take these in and test these and get one that's good. If they all test good, that means they're all bad. Because there's just something that they just don't work. But this thing is working now. And this is really all I need it to do is right here. Is now I can build my little board. And I removed the 670s that were right here. I removed those and put new ones in. The old ones are right here. I'm just going to put these old ones back in the board and keep my 670s. So yeah, but I'm going to build my my little ROM board and then remove all the program and put it right here, and that should work. But yeah, there you go. Man, these stupid things. I'm gonna test these, and I got one more of these I'm gonna put right here, and then I'll only need one 244 for right here. So I'll go ahead and do that. Alright, yep, this is absolutely crazy. I tested these in my chip tester, my TL866 chip tester. One of them definitely tested bad. The others tested good. I just put one of them in here and it will not run. So I'm going to go ahead and try a different one. And no, this thing will not run with any of these. And they're all, these three tested good in my chip tester, and this will not work. But if I turn it on without it, it'll run. The light's off, and there she is. These things, I don't know if they're tri-stating properly. These are 244s, LS244. Come on. No, 244D? I don't know. They're junk. They don't work. And I don't have any more other than those. So, yeah. But a regular Texas Instrument 244 is fine. It just doesn't make any sense. So, yeah. I'll try to see if I can't scavenge up one of these out of a board around here or something. Let me do that. Alright, and this is the little ROM circuit board for Tempest that I designed. I'll flip it over. The 138 and the CD 4068. Now on my members section, channel members section, and over on Patreon, you'll be able to actually find this board for download, the files. I upload all of my stuff like this that I do. I upload all of this to Patreon. So yeah, if you're interested in checking some of this stuff out, or just supporting the channel, or anything, you know, channel membership or Patreon. But I have a video that I uploaded on both Patreon and the members section here on YouTube of start to finish designing this board, laying out the schematic, and then laying out the board and all of that. So yeah, really cool. So I'm going to go ahead and build this thing up. I have bought these two little parts. So I have those. I have the sockets, so we're good to go. Let's get this thing built up. Alright, and there you have it. All built. The one thing is, you do have to split the 28-pin socket. I don't have the decoupling in. That's just 0.1 microfarad caps. I got 3 of them, 4. Spaces for 4 decoupling caps. And on the back side we have our 2 ICs. There. It's good to go, and I have my Tempest EEPROM ready to go. So I'm going to go ahead and remove this CPU. CPU goes right here. ROM goes right there. I'm going to remove all of these ROMs, plug this guy in, and see what happens. Alright, well, we're back with the Tempest board. The Tempest PCB. ROM PCB. This was my first one that I designed that had the 2 decoding chips. I've since removed them because this thing didn't work. It just did not work. So I rethought what was going on, and obviously it's got to do with boot vector or something like that. I think it has to do with the way the game starts up and the address that the CPU starts at, I think. So I've redesigned it to this. And one thing I did was I moved this 27256, the 28-pin socket. Like, see how I had it kind of straddled right here? I didn't like that. I had to separate the socket. I switched it to where you don't have to do that now. The socket will just sit right there. And what I did, you see I got 244 here, 244. I did not realize that there's 2 different form factors for SOIC surface mount parts. I'm not very versed in surface mount stuff, so I didn't realize that. So what I've done is I've put footprints on here. You can use either form factor, either or. I think I have this form factor here, so this is the one I'll be populating. But what I'm doing with this, you can see there's the 244 there. What I'm doing with this is I'm going to remove this 244 from the board, physically from the board. And I have run these lines from the ROM and from the CPU to here. This 244 on this little board takes the place of this 244 here. And all I have to do is pick this signal right here, F4 pin 8. That enable signal. I have to grab that off of the board and run it up to right here, and I have a little via for that. F4 pin 8. And this is just for if you want to use a 2750 256 or 512. I actually don't think this matters. I think you can just short this to ground or to VCC and it'll be fine. I'm going to mess around with that. I'm going to put a 3-pin header in here and use a jumper to test around on it. But I'm going to go ahead and give this a shot, see what happens. Well, I was about to pull my hair out because this board that I made wouldn't work. I actually tried one of these little boards with wiring up the actual address lines and everything to it, and it didn't work. And I was like, I don't understand why this isn't working. This should work. It's not that difficult. Well, I did a little research, and it turns out, and this actually crossed my mind about boot vectors. The 6502 goes way up in the address range to get boot vectors. And the way that this works is you have to have the last 8K of ROM mirrored at the top of the range. And that's where it gets its boot vectors. So I did that. I put the ROM together and I put the last 8K up at the top of the range, put it back together, and it works. Just like it should have worked. Now, I remember one time, this jarred my memory, I got a Tempest repair in once, and it had a single ROM hack right here. And what I found on the internet was pertaining to this single ROM hack, where you actually remove the socket and cut traces and stuff like that, which I do not like. My thing here does none of that. There are no cut traces or anything like that on this board. All it is a little satellite board that plugs in, and this ROM has its own buffer. This is a 244. Remember, I showed you can use either package. This ROM has its own 244. It takes the place of this, so you can actually remove this. See, I'll go ahead and turn it off. This is completely out of the circuit now. This was the driver for these ROMs. These ROMs are not used anymore. So you can actually just remove this. You do have to run one jumper wire here. One jumper wire. And I'll show you what that wire is right now. If you see right here, I think I went over this already. This right here, F4 pin 8, is the enable to the driver. Now what I did was I used a 244 between my single ROM and the CPU. Okay, that's that 244 right there. I basically just took this, whereas this is the insulator for these ROMs and the CPU towards the system. This now is the insulator between my ROM, the CPU, and the system. So I basically just took this and moved it up here. Not exactly though, because this needed its own separating driver. So that's what the purpose of this is. But this you can just remove it now because these ROMs aren't used. So yeah. Just turn it back on. Yeah, see? Perfect. So yeah, my 244 is the buffer between this ROM and the CPU. And I'm just using the same signal that the other one was using. I just grabbed it right here. The trace goes from pin 8 of this guy, F4, and it comes all the way down to that via. So I just grabbed it right there, that via, and I have a via on my board. That's it. And this is a 27256. And I also took this file and I doubled it and I burned it into a 512 because I just want to verify this works too. It should work as well in a 512. So you can use it. But what I was wanting to get to, I recall one time I had a Tempest repair. And I remember the single ROM hack it had on it would freeze the screen. I remember, I don't know if you go back, you could find the repair on my channel. I might do that. But it had a single ROM hack on it, and it would freeze and crash. The file that is online for that hack, there's a page that you can find with this single ROM hack. The ROM file that they have had like 100 differences from the one that I compiled. I compiled using version 3, the final version of the files. So it's got all the fixes and everything like that. But maybe that's why that board crashed so much with that single ROM hack, is because the one that online is no good. So yeah, I believe that's it. So this one's good to go. Yeah, I'm going to put it through its paces a little bit. I'm going to test this thing a little bit and make sure all of the stuff works on and test and everything like that. And I want to try this 512 ROM, just verify that that works. But yeah, this is a nice little, I really like this. I put this jumper on here. I don't even know if this is necessary. I put it on there because I don't know. Yeah, so I don't know. But yeah, this is not a hack. You don't hack anything. There's no cut traces on this board whatsoever, not a one. So yeah, it's a good solution, and this is a good sized little board, and it's you know, it's a nice little board. So I'm going to set the camera up on the tripod and we'll go through some of the testing stuff. And yep, I just took the 512 and I popped the 512 in here, and it works just the same. Good to go. So this is really unneeded. This can be just jumped to, I don't know if you can see this. Let me get one of these. This says address bit 15 over here in VCC. You could just take a jumper and put between the center pin and VCC. And this is not needed at all. So I put it in there just in case, but it's not needed because it's the same setting for both the 512 and the 256. Okay, I want to go turn out the lights a little bit and we'll try to do some testing and adjusting. Okay, how's that look? Good. I'm going to put it into test and reset it. All right, you know what's interesting? The updated version, the most updated version of this, I believe, has a little spinny thing right here. So I was under the impression that I used the most updated version of this software, and I thought I did. But I'm going to have to look into that, because this should be that. I think it should be the spinny thing. I don't think it should be the numbers or the letters. Numbers and letters. I'm not exactly 100% sure on that, though. It's all good. That's elementary. I'm going to look into that, though, for sure. So I want to make sure that I got the most recent version of the software here. Linearity's a little off there. Needs to be a little bit more like that, maybe. Make those boxes all try that. Okay, yeah. That looks better. It's a little bit better adjusted. Boy, that looks sharp. That looks really good. This monitor has a little bit of a pin cushion thing going on. That's all right. This looks great. Sweet. I'm going to go turn the lights back on. So there you have it. Nice little ROM board to eliminate this bank of ROMs. And this, you can leave it in, you can cut it out. Me personally, I would just take my flush cutters and cut that chip out of there and leave the legs, whatever. That's what I would do. But yeah, there you go. Nice. And always, this is, now it's tested, I'm going to release it and put it on my Patreon page. And it'll come with a 256 file and a 512 file. And I'll maybe make a snapshot of this. Go with my camera. Photo. And make a picture. Not a video. Darn it. Alright. I'll be right back. Okay, yep. I took a couple pictures. Take a picture of this. It'll have instructions and all that. But, and I am going to make sure that the software is the most recent version, because I'm under the impression that the line thing that does the line that moves around when you use your trackball and test, I always thought that was the most updated version. So that's interesting because I used the 4K files when it's called concatenated or whatever, where you put them together. I used the 4K files that were in MAME to put that together. And I thought that those were version 3, the most recent, but I don't think that they are. I'll be honest, I don't. So I'm going to put together another set, and I want to make sure that I have the most recent, the best software for this game. Okay, yeah. With the ROM files, I did use the older version. The 4K ROM files are numbered 133 in MAME. This is MAME now. 133, 134, 135, 136, and 137. Those are the 5 files that I used to put the ROM together. Well, there is an updated one. There's a 235 and a 237. So I went back and I redid it and burnt a... Man, I just ran out to the car. I'm out of breath. Or back to the house. A 256 and a 512. So, and I went ahead and I removed the socket and I soldered this thing directly into the board. And there are two, I'll show you. There's two little loopy things right here. Those two guys. The power reset and cat ST. Those loops. I just took my little pliers here and I grabbed onto them and I just folded them over in half. Just bent them over, no big deal. So this is soldered directly into the board, so you don't have to worry about it getting hit and coming out or anything like that. I removed the socket and just soldered this right to the board. So this is the most, the final revision of Tempest. So we should be good to go now. So I'm going to go ahead and hook it back up. All right. Yeah, we're hooked back, all hooked back up. And we are rolling. And I'll show you what I meant. We'll put this thing back into test and you'll see the spinny thing for the spinny thing that you use for the trackball tester is like a line that just does a circle. So instead of numbers and numbers and letters. So we'll hook back up and go back through it. Okay. It looks like this version of the ROMs has squeezed, or that could just be the pots. Who knows? Go turn the light off. Okay. We'll put it into test and reset it. Yeah, see, it comes up with that line. That line spins around like that. Yeah. Yeah. We'll step through the test. These are our inputs: zap, one player start, and fire. Okay. And now we'll go through coin inputs. coin inputs. Yep, I think it looks good enough. Go turn the lights back on. Okay, let's take this baby out of test. There you go, Tempest. Nice. Yeah, so you can find this amongst other things. My little Battlezone kit that I made too. I have a Battlezone kit that is a single ROM thing. Battlezone was a little bit more involved actually. This one was easy, other than it was throwing me with you having to double the last 8K of ROM at the top of the address. That was throwing me for a loop. And you can use either a 512 or a 256 without messing with this. You can just put a jumper, remember, from VCC to the center pin. You don't need to even mess with that. So yeah, very good. This amongst with a lot of other things that I've made are on Patreon if you're interested, or you're just interested in helping support what I do here. This is something I just created to make things easier for people, better, eliminate this whole bank. And for purists like myself, this is the original code. This is the original hardware. We took the 244 buffer between the system and the CPU and moved it to right here. It's the same hardware. It just eliminates this. And there's no hacking on the board. Not one trace was cut. And that's how it should be done. So, excellent. There you go, Tempest. Thanks a lot, guys. We'll see you all on the next Classic Arcade repair. Bye for now.